strings not referenced by dicts? Look at this Python code. It prints false. That's weird by itself, but becomes much weirder when you consider the following. If x is a number, int, float, complex, fraction, decimal, instead of a string, it still prints false. For bytes and byte array, too. But for every other type, hashable if used as key, like tuple or frozen set, but many other, if used as value only, it prints true. If D is any other container, set, list, tuple, containing x, it prints true. Only for a dict, it prints false. Also, it doesn't matter if x is a key or a value, or as above, both. I thought in Python every object is a reference, as opposed to Java, which has primitive types, or Ruby, which value types small ints, but now it seems str and int are kind of primitive types, that aren't referenced. But on the other hand, why only in dicts? I also know that ints from -5 to 256 are cached in Python, and small strings can be unturned, so it makes sense not to reef count them, since they will never be deleted anyway, but this works for any integers, and long strings, I've tried, much larger than that range. Does anybody know what's going on here? Update. Curiouser and curiouser. It seems date time, date, time, classes have the same unreferenced behavior. Now, I know one thing that those, any str and number have in common, their hashes are randomized with A/session salt. But this doesn't make any sense, since the behavior is observed even when these are merely values in dicts, not keys. And values are not hashed. Or are they?
From gcmodule.c. Certain types of container cannot participate in a reference cycle, and so do not need to be tracked by the garbage collector. Untracking these objects reduces the cost of garbage collections. However, determining which objects may be untracked is not free, and the costs must be weighed against the benefits for garbage collection. Dictionaries containing only immutable objects also do not need to be tracked. Dictionaries are untracked when created. If a tracked item is inserted into a dictionary, either as a key or value, the dictionary becomes tracked. During a full garbage collection, all generations, the collector will untrack any dictionaries whose contents are not tracked. Basically, since objects in Python are reference counting, the goal of garbage collector is to break reference cycles. Other unreferenced objects are destroyed when last reference goes away. For optimization, garbage collector doesn't keep track of certain objects which simply can never participate in reference cycles. So, strings are referenced. However, the garbage collector is not interested in these dictionaries at all, and therefore gc.get_refers doesn't list them.